This is a video lesson for lesson 16 through 18 of Module 5. The learning target for all these lessons is I can add and subtract fractions with similar units. So this is going to be kind of like a quick boot camp where we're going to be looking at a whole bunch of different examples of adding and subtracting fractions with similar units. So I want to go ahead and jump into it and get started. So the first problem I'm going to be working on here is a subtraction problem. I'm going to be subtracting 7 ninths, the problem I'm going to be working on is 7 ninths minus 3 ninths. And I'm going to be using a visual model of a number line to show what's happening when I subtract these numbers. So to start out, I'm going to represent 7 ninths, the minuend, on the number line. I've already partitioned my number line into ninths, so I'm going to count up to 7 ninths. And I'm going to mark that and label it on the number line. And then to show the subtraction of 3 ninths, what I'm going to do is I'm going to be moving in this direction, and I'm going to jump 3 ninths that way. So I'm going to go 1, 2, 3. I'm going to end up at this point. So I'm going to show that subtraction by labeling one jump here. And so show that I jump 3 ninths. And my answer is going to be whatever the point is that I landed on. In this case, that is 4 ninths. So I get an answer, 7 ninths minus 3 ninths equals 4 ninths. So you might notice that the numerator of our answer is simply the numerator of the first number minus the numerator of the second number, and our denominator in this case stayed the same as the denominators in the original problem. So that's going to be important to doing subtraction without the number line, which is what our next example is. So in this problem, I'm going to be showing how to subtract 7 twelfths minus 3 twelfths. So just like we looked at above with our previous problem, we saw that we can simply subtract the numerators, so 7 minus 3, which means that my numerator and my answer is going to be 4. And then I'm going to keep my units the same. So I'm keeping 12 as my denominator, so I get my answer of 4 twelfths. So you can see that subtracting fractions with similar units isn't so much of a complicated thing. We simply subtract our numerators and we keep our units the same, or our denominators the same the whole time. So there's a similar method we can use when we're working on addition. So we're going to be looking at the problem 3 tenths plus 6 tenths, and once again I'm going to use a visual model of the number line. To use the number line, I'm going to start by representing this first number, 3 tenths, my first addend on the number line. So I'm going to find 3 tenths on the number line. And I already split this number line into 10 equal parts, so each of the dashes equals 1 tenth. So at this point it's 3 tenths. And I am going to jump to the right, or jump forward 6 tenths, which will get me to this point right here. And I'll show that addition by showing the jump and that I am adding 6 tenths. So I went 1, 2, 3, 4, 5, 6 to get to my point right here. And then whatever I end up at is going to be my answer. In this case, 9 tenths. So I am able to find that 3 tenths plus 6 tenths is equal to 9 tenths. So you might have already noticed that just like subtraction, essentially what we just did is we added the numerator, or the number of units in each of these numbers, 3 plus 6, and that gave us our numerator for our answer, 9. And then we kept our units the same, so we kept it as tenths the whole time. So we never changed our denominator. It's always tenths, 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 tenths for this problem. So that's going to be important for solving addition problems with fractions without the number line, which is our next example. So in this problem here, I'm going to be adding 3 fifths plus 4 fifths. So like we just discussed, the units, or the denominator, is going to be the same, and we're simply going to be adding our numerators. So 3 plus 4, which in this case is 7. Now we get an answer here that is an improper fraction. Improper fractions are fractions that are greater than 1, where we have the numerator larger than the denominator. So I'm going to represent this as a mixed number, which is a mix of a whole number and a fraction. And to do this, I'm going to use a number bond, and I'm going to pull out one whole in fifths, which in this case is 5 fifths. And since I took away 5 fifths from the 7 fifths I have, that leaves me with 2 fifths. And to get my mixed number, I simply represent that 5 fifths as one whole, and then the 2/5 stays as a fraction, so I get an answer of 1 2/5. So just like with our subtraction, adding fractions that have similar units is not too much of a tricky thing. So let's go ahead and move on to some more difficult problems here. In this problem, I'm going to be subtracting 1 1/5 minus 2/5. So it's a little bit trickier because our minuend is greater than 1. But we're going to use the same method when using the number line here to subtract this fraction. So I'm going to start by representing 1 1/5 on the number line. I already have my number line partitioned into fifths, so 1 1/5 is right here. And then I'm simply going to make 2 jumps to the left on the number line because I'm subtracting, and I'm going to end up right here. And so I figure out where I am on the number line, which in this case is 4/5, and that gives me my answer. So I started at 1 1/5, I subtracted 2/5, and ended with 4/5. So there's a little bit of a different strategy we use when we're moving away from the number line and subtracting fractions that are larger than 1 whole. And what we're going to do is we're going to take this mixed number and we're going to rewrite the problem with the mixed number as an improper fraction. So we know that 1 whole is the same in thirds is 3/3. So essentially 1 1/3 is the same thing as 3/3 plus 1/3. And that's pretty much the same as 4/3. So what we can do is we can rewrite this 1/3 and view it as 4/3. And then we're simply able to do the strategy we used previously when subtracting fractions. We keep the units the same, so thirds stays the same. And then we simply subtract 4 minus 2, and we get 2/3 as our answer. So the steps to subtracting fractions when we have a mixed number as our first minuend is we rewrite the mixed number as an improper fraction, and that allows us to subtract easier. Things get a little bit tricky as well when we're working on adding fractions that are greater than 1, but you might find that it's a little bit simpler than subtraction. When using the number line, we're going to use the same strategy we've been using previously. We're going to represent our first addend on the number line. So I already have my number line split into thirds, so there's 1 1/3. And I'm going to show the addition of 1/3 by jumping 1/3 forward on the number line. So I added 1/3, and so I end up at 1 2/3. So that's my answer, 1 2/3. So you might notice that I simply have combined my 2 fractions here, and those are now represented alongside the 1 whole that I had at the beginning of my problem here. So when we're adding fractions without the number line, that's essentially the strategy we're going to use. We're going to keep the 1 whole, and then we're simply going to add these 2 fractions together. And so we're keeping the units the same and adding our numerators. So 1 plus 2 equals 3. So we get an answer of 1 3/5. So it's kind of a simple thing when we're adding fractions that are greater than 1. The final thing we're going to look at today is subtraction and addition problems with with at least 3 different parts. So in this first problem here, I'm going to be solving the problem 1 minus 3/10 minus 1/10. And there's a couple different ways that we can do this problem. So I'm going to be showing both of them. The first is to take our 1 whole here and represent it in the units that the other fractions are in. So tenths. So I can represent 10/10 to equal 1 whole. And then I'm going to solve the problem in 2 parts. I'm first going to subtract this first fraction here, so 10/10 minus 3/10, which will equal 7/10. And then I'm going to take this answer, and then I'm going to subtract the next fraction in the problem. 7/10 minus 1/10 equals 6/10. Now another method I could use is I can actually combine these 2 subtrahends, or the numbers that we're going to be subtracting from the whole. I can combine them together and then subtract them from the whole. So I could combine 3/10 and 1/10 by adding them together, and that's 4/10. And then I'm simply solving 10/10, which is the same as the 1 whole, minus 4/10, which equals 6/10. So I can either solve it in 2 parts, like I did right here, or I can combine these 2 subtrahends and add them together and then subtract them from the whole. So both ways end up in an answer of 6/10. And just like with subtraction, when we're doing addition with multiple add-ins, we have a couple different strategies we can use to solve this problem. The first strategy is we're simply going to add up all the numerators of the problem. So using our addition strategy, we keep our units the same. Since we're working with 6, our answer is going to be in sixths. And we just add up all the numerators. So 1 plus 4 is 5, plus 2 is 7. So we get 7/6 as an answer. And I'm going to use a number bond here to rewrite my answer as a mixed number. And so we get 1 1/6 as an answer. So that's one of the methods. We simply add up all the numerators, leave our units or our denominator the same, and if we need to, we rewrite it as a mixed number. Another method is we can look within the add-ins, so the different parts of the addition sentence, and see if we can make one whole. So in this case, I can see that if I added 4/6 and 2/6 together, that equals 6/6, which is the same as one whole. So if I combine 4/6 and 2/6, I'm simply adding 1/6 plus 1 whole, or 6/6, and that gives me an answer of 1 1/6. So looking within the addition sentence to see if I can pick out 2 of the add-ins that equal 1 whole is another great strategy for adding multiple add-ins with fractions. So there it is. That's our big boot camp for adding and subtracting fractions. This is definitely a video that will be worth coming back and rewatching if you get stuck. So thanks for watching and good luck.